In this example, I need to verify the identity, the cosecant of x minus the sine of x equals the cosine of x times the cotangent of x. Now remember, in verifying identities, we either want to start on the left-hand side and prove it equals the right-hand side, or we want to start on the right-hand side and prove it equals the left-hand side. And we always want to start on the more complicated of the two sides. That's kind of hard to tell in this problem, but I think I'm going to start on the left-hand side because I have two separate terms that I can combine into one term, which is easier than taking one term and breaking it down into two separate terms. So I'm going to start on the left-hand side. And as I have cosecants, sines, cosines, and cotangents, the easiest way to solve this problem, I think, is to write everything in terms of sines and cosines. So here are some useful identities for this problem. The first thing I need to do is rewrite the cosecant of x as 1 over the sine of x. So my left-hand side becomes 1 divided by the sine of x minus the sine of x. Now I need to combine these two terms. As the first one is a fraction, I turn my sine x into a fraction by dividing it by 1. And how do we combine fractions? We need a common denominator. Since I only have a denominator of sine x, that is my LCD. So I have to multiply this denominator of 1 by sine x to get my LCD in the denominator. As I multiply the denominator by sine x, I must multiply the numerator also by sine x, because what I'm really multiplying by is 1 in disguise. So now my denominator is the same in both cases, so it's over a common denominator of sine x. And in my numerator, I have 1 minus sine x times sine x is sine squared x. Now, has this got us any closer to the right-hand side? Not yet. But looking at our numerator, when you see 1 minus sine squared x, you should see Pythagorean identities. Because if I take sine squared x plus cosine squared x equals 1, and I subtract sine squared x from both sides, I get cosine squared x equals 1 minus sine squared x. So now, instead of this 1 minus sine squared x, I can write cosine squared x. So I'm going to get cosine squared x in my numerator divided by sine x in my denominator. Now things are looking better. At least I've got a cosine x present. And now I also need to get a cotangent of x over here. Well, that's the cosine of x over the sine of x. So what I'm going to do is break this cosine squared x down into cosine x over 1 times cosine x over sine x, because cosine x times cosine x is cosine squared x. 1 times sine x is just sine x. So now cosine x over 1 is just cosine x, and cosine x over sine x is equal to cotangent of x. And now, is that my right-hand side? Yes. So I have shown that the left-hand side equals the right-hand side, so I have verified this identity.